Okay, guys, so this is the last lesson of the unit, and it's called tangent line approximation. Another name for this is linear approximation. So, so I'm just going to lay out for you a formula and like how it works, and then we're just going to do two examples, and they are much easier than what we've been doing this unit. Okay, so we'll finish with something nice and accessible, immediately accessible. So if y equals L of x is the tangent line to the graph of y equals f of x at x equals a, then for a value b super close to a, f of b is going to be approximately L of b. All right, so here's a little picture of what that means. So if L of x is the tangent line to the graph of y equals f of x at x equals a. So let's translate that. So so this is the tangent line, L of x, to the graph of this function, f of x. And, there's going to be a different tangent line depending on like the point on the original graph that you want the slope at. So this is the tangent line at x equals a. Okay, so there's the x value a. Now let's assume that b is super close to a, like right over here. I know I left a space here, but it was just so you could see well, but b would be more like a.01 or a.1 or something like that. And what this is saying is that then for a value b, right here, super close to a, f of b is approximately L of b. So if you go up to the graph and find the points, both points on the line and the original, if you look at both of those y values that you get when you plug b in, they're really close. They're pretty close. So what they're saying is that this y value, f of b, is an estimate, can be estimated by the y value L of b. Okay, now we're going to use a formula to do this. This is the formula for the tangent line at x equals a. We just used this like yesterday, and then we also used it earlier in the year. It goes like that. And then the formula for the tangent line approximation for numbers close to x equals a, all you do is you take this y and replace it with L of x. Okay, so it's the same exact formula, but y is replaced with L of x. All right, so I'm going to do two examples. So example number 1. Given that f prime of 1 equals -1, use linear approximation to find an estimate of f of 0.9, and then based on the graph is your answer, period. And then based on the graph is your answer an overestimate or an underestimate. All right, now guys, they're giving you this, so right here, so this is L of x, which is that line, and then this is f of x. And now let me find f of, like, let's just say, pretend that this is like blown up or zoomed in a lot, so it looks like there's a lot of space between these x values. Let's say that that's 0.9 right there, okay? This y value right there, that y value is on f of x. So this is f of 0.9. And then this y value right below it, that is on the line L of x, so that's L of 0.9. All right, so what we're going to do, guys, is we're going to find the equation of this tangent line, and then we're going to plug 0.9 into it, and that's going to give us an estimate for f of 0.9. Alrighty, so I'm going to write down the formula. The formula is L of x equals f of, in this case, it's 1 plus f prime of 1 x minus 1. All right, so I just used this formula right here. And in this case, A is 1. Okay, so L of x equals f of 1 is negative 2/3. All right, so that's 1. This is f. So the y is f of 1. That's the output. Plus f prime of 1, they actually gave us. So plus negative 1, x minus 1. So I'm just going to simplify a little. Negative 2/3 minus, you could say 1 if you want, x minus 1. And you could just leave it like that. Okay. Now, so we found the equation of the tangent line. That's what this is. And then so we're going to find L of 0.9. And now at this point, you could just use your calculator, but it's going to be negative 2/3 minus 0.9 minus 1. Then I'm just plugging that in. Minus. Okay. And I mean, I got a decimal, but the fraction version is this. Yeah. So I guess, yeah, so I could say, so I could be like, so now I'll just say f of 0.9 is approximately negative 17/30. All right, so that is the first thing that we wanted. So we've done an estimate of f of 0.9. Now, based on the graph, is this answer an overestimate or an underestimate? Well, guys, just look. So f of 0.9, that's actually above L of 0.9. So this is an overestimate. No, it's an underestimate. That's an underestimate. Because, yeah, because L of 0.9 is below the actual function value. Okay, let's do one more. So given that f prime of x equals all of that, use a tangent line to estimate the value of f of negative 1.01. Based on the graph, is your answer an overestimate or an underestimate? Okay, so we're going to do the same exact thing. So negative, let's just say, and again, just pretend this is like zoomed in a lot, so the space between the numbers looks big. And then I'll go up to the graph. Okay, so this one below, that is f of negative 1.01. And then this one is on the line, so that's L of negative 1.01. And guys, let's talk about the over-underestimate thing right away. This, oh yeah, so maybe I'll say this. So this is going to be, this y value is over the other one. Let me go back here. This y value is under the one that we're being asked to estimate. All right, so that'll help us later. Okay, now I'll write down the formula. So L of x is going to be equal to f of negative 1. All right, so you're going to use, so the x value that you're using is like whatever x value there is for the point of tangency. Negative 1 plus f prime of negative 1. X minus negative 1. So that's going to be a plus. Okay, so L of x equals f of negative 1 is whatever y value like goes with it. So that's 2/3 plus f prime of negative 1. Now for the last example, they just outright gave us the value of f prime at the x we wanted, but this time they're giving us the formula for f prime. So I'll go like this or something. So f prime prime of -1 equals 10, -1 plus 1 to the 4th, minus 12, -1 plus 1 to the 3rd, plus -1 squared. These are both 0, so you just get +1. So in for this f prime of -1 goes a +1, and then that's x plus 1 in there. So I'm going to get L of -1.01. And I'll see what that is. Oh, yeah. So it's going to be 2/3 plus -1.01 plus 1. Minus. Oh boy, that's kind of big. All right, so then I get 197 over 300 from my calculator. So then I'll just state my final answer. So f of -1.01 is approximately that. Okay, and remember that the line, since the line was above the graph, it's going to be an overestimate. Overestimate. Okay.